Frank Goldner is scheduled to speak next on advanced fuels R&D. Unfortunately, he is currently on travel overseas, so I will be presenting this work scope on advanced fuel development, FC2, in his stead. If there's any questions related to this as we go through, please still feel free to ask them. I should be able to answer most of them, but if there's anything that we can't answer right now, we will record it and provide an answer on the Q&A section as a follow-up. The Fuels Campaign falls under the Fuel Cycle Research and Development Program. It has three main focuses, as you see here. The first is on, and this is the newest focus area, is on advanced LWR fuels with enhanced performance, safety, and reduced waste generation. This is also commonly referred to as fuels with enhanced accident tolerance or accident-tolerant fuels. This is the area where we 2 years ago initiated multiple IRPs to address the near-term needs to develop these new fuels. The second main thrust of this program is on transmutation fuels, coordinated with the rest of the fuel cycle R&D program, focusing on examining the different fuel cycle options, closed fuel cycles, and reprocessing, utilizing advanced fast reactors, for example. This portion of the program is currently focused on metallic transmutation fuels. We realize and are working closely with international partners to complement the U.S. focus on metallic fuels with the international focus on oxide and ceramic fuels. The third component is more of a cross-cutting component, capabilities development for science-based approach to fuel development. This is where we investigate things like advanced characterization and post-radiation examination techniques, in-pile instrumentation, which is done in close coordination with the NEAT Advanced Sensors and Instrumentation Program. We also look at separate effects testing, and that work is done to support much of the modeling efforts that are done under NEAMS and to further move forward some of the science-based R&D. Also here you'll see transient testing infrastructure. One of the significant needs for developing any new fuel and qualifying it for use in power reactors is the need to understand its behavior during accident scenarios, and transient testing is one of those steps towards ultimate licensing. This year we have a separate work scope, actually an IRP, which I will discuss tomorrow, related to specific transient testing R&D needs, and all of that work is done in close coordination with the fuels program here. You note the arrow linking to NEAMS, the Nuclear Energy Advanced Modeling and Simulation Program. They are separate programs here in the Office of Nuclear Energy, but they work very closely together. The Moose, Bison, Marmot code that's being developed under NEAMS is of direct support to the fuels program, and much of the data that the fuels program is producing helps advance the fuels product line under NEAMS. For those of you who heard the overview presentations earlier, this is one area where there definitely may be some data validation needs as identified in Appendix D. So if you're interested in this work scope and submitting a pre-application, this is definitely an area where there's likely to be some connections. The Fuels Campaign has, as you see here, has some high-level technical objectives. These are 5 years, so they're more near-term objectives. The first of which is identifying, selecting the best concepts for advanced accident-tolerant fuels. And the goal here is to demonstrate a lead test rod within the next 5 to 7 years. it's a very, initially this program was on a 10-year timeline, and it's moving very quickly, and we're continuing to look for new ideas while evaluating the progress of the ones that we have previously solicited. The focus initially is on near-term concepts that can go into a current LWR soon, but we're also evaluating longer-term concepts that may require many more years of R&D leading towards demonstration. So this would cover both of those. We're also looking for conceptual design for transportation fuel technologies, and the emphasis is understanding the fundamental behavior of these fuels and the different properties and performance of various options. The third bullet, identify and demonstrate feasibility of innovative concepts. Again, that's similar to what I mentioned previously. We have some near-term focus with specific needs, but all the way through we're continuing to evaluate and consider innovative transformational options. We're looking to develop, achieve state-of-the-art infrastructure. This ties to the cross-cutting piece of the program mentioned before. This could be for characterization, PIE, in-pile, real-time instrumentation, transient testing, instrumentation, as will be discussed in the future. The last bullet is to link all of the R&D here to the NEAMS modeling program. And you see on the right some of references to some of the major documents that can provide additional information to you. And most of these should be found on our NE webpage or by contacting Frank Goldner or John Carmack, the main POCs for this program. And I should note that both of their emails are listed on our overall points of contact on the NEUP website and also at the end of this presentation. Some specific goals for the accident-tolerant fuels program. One of the main things is to start radiation testing in the Advanced Test Reactor at the Idaho National Lab. Many of these initial tests will just be small, quick, rabbit-type capsule tests, and then the concepts that prove most promising will be further developed and further tested. We're developing support infrastructure at the national labs to support the fabrication, irradiation, and general testing of accident-tolerant fuel concepts. I know there's been significant work on steam testing capabilities that are being developed at Oak Ridge National Lab, as well as complementary activities at the Idaho National Lab. An initial test planning and preliminary design of a testing loop for use in the ATR is needed, and the point of this will be to investigate the cladding and coolant interactions, which, as we know, was a major concern and led to, contributed to the accident at Fukushima. We're also looking at beginning preliminary design of a transient test loop. This would go in a transient test reactor and would be a water loop to simulate the behavior in LWRs. The last item here addresses multiple FOAs. Over the last several years, the fuels program has competitively solicited for ideas and design developments of accident-tolerant fuel concepts from both the nuclear industry and through the NEUP program as IRPs in 2011. And all of those awards are progressing and contributing significantly to the overall program. Some of the longer-term transmutation fuel needs are identified here. You'll note that they're looking forward, moving forward towards a 2050 demonstration of full recycle at engineering scale. That is an overall goal of the fuel cycle R&D program, and the sub-bullets here are the activities specific to the advanced fuel development in support of this. They're looking at advanced casting and fabrication techniques for the metallic fuel, transmutation fuel, understanding the behavior of minor actinides and how they behave in the fuel. We need to characterize the material properties of those minor actinides, and also continue developing advanced claddings that can achieve extremely high burnups. A few more items on the cross-cutting technology development activities. As I mentioned, the fuels program is working closely with Nuclear Energy Enabling Technologies, Advanced Sensors and Instrumentation, abbreviated as NEAT-ASI, on advanced in situ and in-pile measurement techniques that can be used to measure properties of fuel while in the reactor. They're continuing development of advanced characterization and PIE techniques, and this work is, much of this is being done at the new Irradiated Materials Characterization Lab that is being constructed at INL and will be the home of future home of advanced PIE capabilities. Continue developing modeling and simulation supports to support the NEAMS fuels product line. And then they will expand that program to include the new addition of advanced LWR fuel concepts. This last bullet is more of a programmatic activity, but I think it's useful for the research community to know. They are working on obtaining quantities of americium and neptunium for use in the domestic program and in conjunction with international programs. The next couple of bullets just identify the specific work scopes requested this year. The first is for advanced nuclear fuel. This is somewhat of a general work scope where we are looking for applications that develop new innovative concepts for both accident-tolerant and transmutation fuels. The second, high-performance cladding and core components, looking for advanced cladding, and you'll note here that the core components piece is limited to assembly components, shroud, wrapper, cladding. Other reactor materials components are included in different parts of NE and will be addressed in various work scopes that will follow the rest of the presentation. You should also note that the fuels program is not currently interested in thorium-based fuels or molten salt-based technologies, so those concepts are not relevant to this year's call. So continue with the focus on LWR and transmutation fuels, but uranium-based. This is the final slide that I'll cover here. It provides the contact information for Frank Goldner, the DOE program manager, and John Carmack from the Idaho National Lab, who is the National Technical Director. They also wanted me to relay the message to please examine the previous awards, which can be found in the archives section of neup.gov. They want to make sure that we aren't duplicating efforts, that we're getting new, innovative ideas that build upon previous work that has been done or is new and innovative and not duplicative of previous work. I also, for your reference after the fact, have 3 slides which I'll just show quickly, outlining some of the 2013 accomplishments of the fuels program. And with that, I will open it to questions.
The next presentation will start in about 5 minutes, so we'll keep the line open if anybody has a question. Okay, here's a question, Brad. Advanced fuels are specifically for LWRs and transmutation rather than next-gen reactor designs?
That is the current focus. There is fuels work. It's somewhat separate from this program related to TRISO fuel development for the next generation nuclear plant, NGMP, the high temperature gas reactor. That is not specifically included in this work scope. The main focus currently is both on advanced LWR and transmutation. You could consider potentially multiple reactor concepts for the transmutation fuel, but those are the two primary options. TRISO fuel is something that they've looked. It was initially for the NGMP, but it is being considered as a possible concept or variations of TRISO fuel as possible concepts for advanced LWRs.
Last year, you have a specific section of nanonuclear fuel. Is this still a topic of interest?
It is not a separate topic this year. What we noticed last year was that having it separate really was probably not the best way to do it. If there's innovative nano concepts, they are welcome to be included in here, but those nano concepts would have to address the overall specific needs of the program. We just felt that through the process, having them separate, they really should have been integrated into the overall mission. So those, if there's innovative concepts, those are welcome.
With the remaining time, could you go over some of the accomplishments in the backup slide?
Sure. Apologize, I did not realize we had so much time still. 2 minutes? Okay. So there's 3 slides broken up by each of the program areas. Sorry. For accident-tolerant fuels, one of the major things that was done this year were to develop the metrics for evaluating the concepts. And the program held both domestic and international workshops to build consensus on the metrics that will be used to evaluate and down-select the fuel options for further development. As I previously mentioned, they awarded multiple competitive awards to industry and to consortia led by universities through the integrated research projects. Steam testing capabilities have been developed, as I mentioned, at Oak Ridge, significant cladding work. High-density ceramic fuels are one of the options being considered, and they began the first irradiation test set, the ATF-1, for insertion in ATR. Transmutation fuel, they've been doing some americium reduction work. A GAX furnace is up and operational for use with monoactinides. Irradiation testing and PIE on a Futurix fuel test that was irradiated over in France. They have that back and are beginning the PIE and finishing it on some of the cases. They're doing some materials irradiation in Russia with Bor 60, and okay. You can see the others, and then just quickly a couple items for cross-cutting, mostly instrumentation and pile instrumentation.